Good afternoon. I'm Tony Duffin. I'm from Corrie Energy Partners, and this is a low energy retrofit case study. Now, before I go into this, I want to set some context. And curiously, we feel we're in a new world here. Excuse me, this has just popped up, which is an energy crisis, high energy bills, and lack of energy security. But actually, 100 years ago this year, 1922, there was an Energy Act passed by government, which included a requirement on the people running the electricity system to put in place price caps because prices were running away. So this is not a new thing. And in fact, if you look back since then, we have an energy crisis roughly 20 to 25 years between them. We had one Second World War, unsurprisingly. 1956, the Suez crisis, we had petrol rationing. 1970s, 1973 in particular, there was a global energy shortage. We had more energy rationing. In 2003, there was another spike in the price of oil and shortages were announced. The government had actually printed petrol ration books, but they were never actually issued. So this is just coming around again. It's not a surprise. So to me, it says, well, why aren't we always building ultra low energy buildings? It's the obvious thing to do to avoid another energy crisis. So I'm going to cover these things. I'm going to introduce the case study building. I will reintroduce the Elcon housewarming guides because they form the backbone of what I do in analysing buildings to find out what energy level you can get down to and how you can achieve it. I'll talk a bit about the process and the stages, and then I will start by taking stock of this building, look at the energy consumption of it and why that occurs. I'm going to also look at the EPCs of this building. I actually happen to have 3 EPCs for this bungalow, all done within 6 months. I commissioned none of them, but I've got 3, and it's fascinating to look at the 3 and ask ourselves how they could be improved. And then I'm going to particularly talk about what can actually be achieved for this building and how we do it. So what is the building? There we go. So it's an old bungalow, 3-bedroom bungalow built in 1923. It was extended. This bit here is 60s or 70s, not exactly sure. It has solid 9-inch walls for most of it, apart from this extension. We're not entirely sure what that is. It appears to be cavity. If it is, it's probably filled, but we're not totally sure. I haven't drilled through that. It has suspended timber floor in the main part of the building. Underneath that is a ventilated void, but that is extremely damp. It needs a lot more ventilation. And in the winter, with the windows closed, the building smells pretty horrible, pretty musty and damp. This part has a solid concrete floor, which doesn't seem to have a damp-proof course. And I mentioned it's been badly renovated. There are several things which have been done wrong to this building by the previous owner. And in the case of the damp-proof course missing in that concrete, they then put on a laminate floor, which has concentrated the damp into the wall, and now there's rising damp coming up inside the building, and it's damaging the skirting boards. So it's ripe for renovation, and a lot of work could be done to improve its energy performance. So these are the Elcon housewarming guides, and they are all highly relevant. So taking stock about establishing what is the state of the building now, why does it have energy consumption at the level it has, and what can you do about it? 4 guides there on the details of what you can do, going into depth on insulation, windows and doors, drafts and ventilation, which we need to be aware of because that can contribute half of our energy consumption in a house. Heating and controls also very important, choosing the type of heating system, how to size it right, and what controls to fit. If you don't get that lot right, then your super efficient building can still overconsume energy. And then a whole house plan. Now, I'm not going to go through all of them. There certainly isn't time. I'm going to jump from taking stock through to the whole house plan effectively. So the last 2 slides are the whole house plan. So what is the process? This is a process that I normally undertake, and I strongly recommend anyone who's doing this sort of thing should do. So start off with a site survey. What is the building? Just look at it, just find out how it's made, look for holes in the building, what sort of heating has it got, what's the pipework, what is the floor, what's in the roof, look at the constraints on what you might be able to do. Things like the way the roof overhangs the walls can determine how much thickness of insulation you can put in. How much depth is there under the floor if it's a suspended timber floor, because that's going to limit you in terms of how much insulation you can put in. So understand what the building is. I have had an air tightness test done on this building, so I know exactly how leaky it is, and it's actually surprisingly good. With that information, you can then do some analysis. This tells you a lot about how the building is actually performing, and you can match that with a theoretical model. And then there is a theoretical model. I always think it's important to put a thermal model together. It's quite some detail. You'll see from the charts at the end, and I hope I can persuade you that it's really useful to understand different elements of the building. You can break it down as much as you like, but to understand where is the heat going and what can you do to reduce that heat loss in a particular area. And you can run the model with many different cases to establish what might be the best option. And then from there, what are the stepping stones to low energy? You can build an indicative plan, you can iterate round and eventually fine tune to your solution. Going back to the Elcon guide, so taking stock is effectively these three here, gathering all the information together to establish where you are, and then the other guides feed into these parts. So a bit more about the building then. This particular building is a very high energy building. There's a measure here, one of the many measures that we can use, 3 watts per square meter of floor area is the rating, and you can see on this chart it's just very poor. I think I've introduced why that might be. So here's some more numbers. It has solid 9-inch walls, so they have a U value of 2. If you've not come across U values before, they are an extremely useful measure of how much heat a particular part of the building is losing. The higher it is, the worse it is. So you want tiny numbers there. The suspended timber floor is also has a U value of 2. Suspended timber floors also tend to allow more airflow into the building, so you get more draft. So that is also bad. That doesn't appear in these numbers particularly. Now, 0.18 is the U value you're now required to meet as of 15th of June, just recently come in. So you can see it's less than 1/10 of what that building was built to deliver. Indeed, in 1923, there were no regulations around the heating and heat loss of homes. They didn't come in until the 60s, and then they were pretty limited. And just to reinforce U values, it tells you how much heat leaks out of a part of the building that the units are watts per square meter centigrade. If you have a numerical or scientific mind, that's really helpful to understand. Basically, it tells you that part of the building has a particular type of performance. And the benefit of knowing that is you know how you can improve it by adding insulation. I said I'd talk about the EPCs, and as I said, there were 3. Curiously, there were 3 in about 6 months in this building before I bought it. The first one was done on the 10th of October, 3rd of October in 2018. And I picked out a few key points from this, which I will compare. It says it's 93 square meters of area. That's about right. That depends exactly how you measure it. It says it had a cavity wall, and it said it had 100 mil of loft insulation in it, which are both wrong. The second one, 31st of January 2019, different assessor, slightly bigger area, correctly identified solid wall, and correctly measured the loft insulation. They are both E-rated. Look at the difference in energy consumption. About a 30% difference between the two for the same E rating. So it's not really very helpful to know your building is E rated. And given that these two have completely different analysis of the structures or identification of structures, that is also not very helpful, because the advice given here is to put cavity wall insulation in, but it hasn't got a cavity wall. And the advice here is, well, that's nearly enough to start with. So the advice on this one was not to bother with the loft, whereas the advice on this one was to bother with the loft. The building is exactly the same in both cases, but the EPC hasn't helped. What's even more curious is then on the 8th of February, so a week and a bit after this one, there are no changes to the building, but a new EPC is issued with a D rating. I can't explain why that's happened. apart from the assessor must have played some tunes on the entry to the spreadsheet.
Was that a different assessment?
That these two are the same assessor. I can't explain why they should suddenly have a D rating from the same building. Nothing changed. I'm concerned that the previous owner put pressure on this guy because they thought they were going from an E to a D. They didn't get an E, so they lent on him and told him they wanted a D and could he do something about it. And I know there are ways you can do that by adjusting some settings. On top of everything else, all of them say hot water comes from the main heating system, i.e. from the gas boiler, but actually all three ignore the fact that it has an electric power shower. There's no bath, so actually a lot of the hot water comes from a separate system, and that should add points to this and make it worse. So the system needs improvement. It's not this for the same building, two different assessors, three different occasions, for some reason has given us a really clouded view of what the building actually is about. So I'll get off my hobby horse now. The real detail then is the results from a thermal model. I'll explain the layout of this chart before we go into the lovely colours here. First of all, we have a measure of how lossy, if you like, the building is up here. It's actually the heat loss coefficient, watts per centigrade. That's the whole building heat loss. Basically up here is big bills. It means you need a large boiler or large heat pump, and it means that the building will tend to suffer in the winters. It'll be cold, might be uncomfortable. Down here is where we want to be, low bills, small heating system or none at all, and comfort throughout the year. I've got three cases here. I've got the current building as my base case. I've then done a stage one where I've had a go at improving the building in the model by insulating the walls. It says here 100 millimeters of external wall insulation. There's a few other things I've done as well. And then stage two, I said, well, okay, can I squeeze it a bit more? Can I get more insulation in certain places? Can I make it more airtight to get to, and I've called it under here passive-ish. It's not certified to passive house standard, but it's very, very low energy. And I think that one needn't have a dedicated heating system. I'll go through the colours now. Now, just to be exciting, Microsoft has decided to swap the order of these spectrums. So the colours are right, but instead of it going up the bars, it's flipped around. So windows and doors are at the bottom. So double glazed already. I haven't actually changed that in this set of models. I could go to triple glazing on that final one if I wanted to just drop the energy a little bit more. I haven't done that. The doors, there's a slight improvement here. There's one very old door, so that's been removed. Otherwise, it's the same. The floor, so the floor, as I say, suspended timber floor, no insulation, big gap underneath. What I've done is I've put in about 200 millimeters of an insulation under the floor and sealed it to make it airtight. So you can see there's a massive, massive gain by doing that. Huge benefit. I put in a slightly different type of insulation, same thickness but higher performance. So we've got another little step down to get to the third case there. The roof, it's actually subsequent to the EPCs, it's actually now got about 275 millimeters of loft insulation, the minimal wall. So here I put a bit more in, and then here yet more again. The wall, solid wall, so external wall insulation, as I say, 100 millimeters of polystyrene insulation. That one is limited by the roof overhang. We call them the soffit under the roof. Can't really go any more than 100 millimeters, or the insulation would stick out beyond the edge of the roof. So what I've done in this case here to go for more is I've said, well, actually we'll extend the roof a bit. We'll actually run another row of tiles at the bottom, so the roof comes out another 100 mil, and I'll put 150 mil of insulation. So quite a complicated, technical and potentially expensive thing to do, but if that's what gets down to passive-ish, then maybe it's worth doing. And then finally, ventilation. This building happens to be relatively airtight. The number is 7 cubic meters per square meter per hour. I won't explain all that detail, but basically the 7 is what's important. The larger the number, the draftier your house. You can get 15, 20, worst I've seen is 60. Design now for new build has to be 8 or better. So what I've done here is I've said I want to go much lower than 7. I've gone down to about 3. At that level, you start to need to have some active ventilation certainly by opening trickle vents, possibly by having individual fans that extract the stale air, bring in fresh, but recover the heat in kitchens and bathrooms. But once you're at that level, it starts to make sense to put in a full, what we call MVHR. So you are actively managing the airflow in the building. If you're going to do that, you might as well speed it up some more. So here I've dropped that number from 7 to 3 and now down to 2. 2 is quite a challenge to achieve in an old building, but since there's such a lot of work going on, especially to the floor, then I think that's realistic. And I have seen that in real buildings where I've been involved in the renovation. So by squeezing down on particularly the big 3, the ventilation, the wall and the floor on 2 steps, and then a bit more fine tuning, we get down to a very, very low number. So what are the implications of that? Well, the current building needs a big gas boiler. In fact, I know there's a 24 kilowatt boiler fitted in there. That means big energy bills forever. So stage 1 would definitely allow a heat pump to be fitted, 8 kilowatt maybe, something like that, about 5k to install if I can use the existing radiators, which I might be able to do because the energy consumption is so much lower, the heat could be got out through the existing radiators. And it would probably have about a £500 a year heating bill. So big step down. But I do wonder if we go down to stage 2, which is close to passive house, so no dedicated heating system. So instead of spending 5,000 on the heating system and having that annual bill, spend more on the insulation. And I think the economics of that one may well make sense for this particular building. I'm now happy to take some questions.
Heat pump. Which sort of heat pump? Air source heat pump or ground source heat pump?
Could be either. I mean, air source will be cheaper, so that price is for an air source. A ground source would be more efficient, so it would have lower bills in the long term, but it will cost more. And for this particular site, it would have to have a borehole. So that adds another, I'm told it's roughly 15,000 for a borehole. So.
And that implies also, because presumably you're pretty much gutting the building.
Yeah, it needs.
So you're putting in a completely different heating system.
Yes.
So any existing radiators gone.
Might get away with the radiators on this one. Rule of thumb is that if you replace a boiler with a heat pump, then the same size radiator only produces half the heat. So the other way of thinking about that is that if you want to use a heat pump, you need to either double the radiator size or halve the energy you need to get into the house. This one, we can go back. You can see this is definitely less than half the heat. So it might be possible to use the existing radiators, but that would need checks later.
But the cost that you're putting into this 3-bedroom bungalow,
3-bedroom, but yeah.
3-bedroom bungalow, is it worth doing? As in,
yeah, good question.
How much is your how much do you estimate?
The refurb. I think the material costs alone are probably 20 to 30,000. The insulation materials. Right. I don't know what the rest of it would.
Sorry, Tony, say that again. The cost is
20 to 30,000 pounds of insulation materials
to get to stage 2
down to there. Yeah, it's you know, some people spend that on a kitchen. It's the value of the property at the end would be definitely increased. The comfort in it would be excellent. The energy bills would be very low. So it's a complicated set of arguments, certainly, but on the basis that it might be saving, you know, compared to the existing bill, it might be saving £2,000 a year on energy bills. If it is £20,000 for the sake of argument, that's 10-year payback, assuming constant energy costs. But I'm confident energy costs are going to go up. And as I said at the beginning, we're going to have another energy crisis in 20 odd years' time. So so let's do it all in one go.
I was interested why, if you're going to so much refurb, you're not putting underfloor heating in?
Yeah, this case here needs heating. The problem is that to get the heat loss down to that level, because of the void, the lack of depth of void under the floor, you either have room for insulation or less insulation and underfloor heating. So it's a bit of a conundrum. If you want underfloor heating, then this green slice will probably double in thickness. So you end up having to spend more on your energy bills and you might not quite meet the target that you want to meet as well. So it's which is another reason why I think actually going down there and not having any heating at all, or the limited amount of local heating. So,
Tony, sorry, is it me?
sorry.
In October, which after all is not very far away, we expect our fuel bills to increase by another 50%. These prices based on today, when you talk about cost effectiveness, are you talking about today's prices? Are you factoring in October's prices? Just tell us what you're thinking.
So I think October's prices make this quite a strong contender, especially when you consider the fact that it would need to have a heat pump. I mean, there are lots of schools of thought on this. It might be that someone taking over this building would go partly down here, and they'd live in it happily with a gas boiler for a while. My view is that this building will probably be refurbished only once, and if it is done properly down to here, then it'll probably last another 50 years without any problem. So my personal view, based on I've done about 100 buildings in theory. I don't get out to site very much, but I've helped architects and their clients with about 100 buildings. Some passive house, some what was called code for sustainable homes, some just better than building regs. And my sense of that, and working with the people who then build them, is that this is now probably the target to go for this particular building.
And would that be a B or an A?
That would definitely be an A.
How would you, sorry, how would you be heating the passive house? Just as you said, just isolated areas of.
Most of the year it wouldn't need any heat. We get what we call incidental heat from just people, you know, you come home from walking the dog and everyone's warm, and the heat just is there from you cooking, the heat from the kettle, the little bit of heat that comes off your laptop, all sorts of things like that just contribute enough most of the year. So there might be 2 or 3 weeks of the year in a passive house where, you know, it's -5 outside and it's gone down to -10 overnight, where you actually have to think about putting an electric fire on for a while. But the heat load is so small, and I can do a quick mental calculation. So this is about 120 watts per centigrade. So I'm going to write that down. So 120. So if we said the delta T, so that if it was -5 outside and we wanted 20 inside, so we need to multiply that by 25. So it's under 3 kilowatts for the whole house, even in the coldest weather. So 1 3-bar electric fire would keep that building warm at -5.
You could put the kettle on.
Yeah, run the kettle for a while. Yeah.
I was thinking about the taking stock element. You were uncertain whether it got solid wall and a cavity wall.
The EPC,
Lots of houses have some solid walls, some cavity
Yes.
walls because of extension. When you're trying to take stock, how do you make sense of that in terms of planning?
Well, first of all, I'm very keen to find out exactly which bits of a building have which types of construction, and it takes quite a lot of detailed inspection of a building to understand it, and sometimes it's not quite clear. There was a phase in construction, sort of late Victorian, early Edwardian times, when they used a narrow cavity, and sometimes it's difficult to tell whether it's a narrow cavity or an original solid wall. So in the thermal model, so this aggregates all the wall, all the ventilation, all the walls, all the roof, all the floor, and so on. But in the detail of the model, I can break it down to individual slices of wall as needs be. So if they're indeed in this building with the extension is treated differently to the solid wall of the main building. So,
Sorry, Tony, one more question, because unfortunately we've run out.
Yeah.
One more question? I'm sure Tony will be around outside for more questions.
I just had a question about, is there a point where it might be better to knock it down and start again from fresh?
I am going to ask that question about this building shortly, and I'm going to employ something called a quantity surveyor. So so this is nearly the design, if you like, is nearly there. I know what needs to be done. I will then supply that information and drawings to a quantity surveyor, who will then work out what would it actually cost to do all that. And I'll want it split by materials, labour and so on. And I will also at the same time, there are many companies, Potton is one example that comes to mind, where you can supply drawings and say, if you made this to the best standard possible passive house, what would it cost? So, and I'll compare the two, to be honest.
Sorry, I'm going to have to end you there. Thank you very much. Can you all please put in your cards for you, please, on your seats? And Tony, will you be hanging around outside?
Mhm.
for it? So please.